In this problem, we are told to find our equilibrium concentrations given our Kc and initial moles. We will be using an ice table to find our equilibrium values, but first, it is worth noting that our ice table would be in terms of molar concentrations. So we can start off with I2, given that we have 0.5 moles, and this would be over our total volume, which in this case is just 5 liters. This would give us a concentration of I2 as 0.1 molar. We proceed by finding the concentration of chloride, given as CO2, and we are given that we have 0.5 moles as well, divided by total volume being 5 liters. So again, the concentration of chloride would be 0.1 molar. Now, since we're given our Kc and a balanced chemical equation, we can proceed and create our equilibrium constant, given as Kc is equal to ICl raised to its molar coefficient of 2 divided by the concentration of Cl2 and I2. What we're solving for is ICl2. So let's create an ice table. I for initial, C for change, E for our equilibrium. Our chemical reaction is given as CO2 gas plus I2 gas reacts to create 2ICl. And this is also in gas. So we have our initial concentrations being 0.1 molar for both CO2 and I2. And we have 0 ICl. The CO2 and I2 is going to get used, so we put this as negative x, and then since there's 2 moles of ICl, this would be plus 2x. X being the change that the molarity goes through to achieve equilibrium. So we can put this as summing up the initial with the change. We have 0.1 minus x for CO2, 0.1 minus x for I2, and 0 plus 2x, which we can just write as 2x. This means our Kc will now look like ICl given as 2x, but that is being squared, divided by 0.1 times 0.1. we can simplify this to look like 2x squared divided by 0.1 squared. Using the property of exponents, we have that Kc is equal to 2x divided by 0.1 squared. We know that our Kc is equal to 9.09, and this is equal to 2x over 0.1 squared. We can square both sides to get rid of our exponent, but this introduces a plus or minus due to us adding a square root. We would just use the positive value since a negative molarity doesn't make sense at all. So we are given that 3.01 is equal to 2x over 0. Sorry, this is all minus x. Zero point 0.1 minus x. Simplifying this, we have that 3.01 times 0.1 minus x is equal to 2x. And solving for x, we are given that x is equal to 0.060. Now, we go back to our reaction table and plug in our value for x. So, the concentration of CO2 at equilibrium is given as 0.10 minus our new x, 0.060, which is equal to 0.04 molar for CO2. The concentration for I2 would be the same, 0.04 molar for I2. And the concentration for ICl would be given as 2 times x, which is 2 times 0.06, and it would be given as 0.12 molar.